Greetings. So today's class in embedded programming will see about the memory of Atmel 89C51. The random access memory is an internal memory and it is used to store some temporary data. And this is the programming model, and you can see here the internal RAM is of about 00 to 7F, that it has got about 128 bytes of RAM. And this is with the 8051 programming model what is given, and this has got some registers like A and B register, IP, IE, TMOD, TCON, THO, TLO, TH1, TL1, SCON, SBUF, PCON, PSW. All these are the special function registers, and you have a data pointer which can be used as two 8-bit registers as DPH and DPL. The program counter is a 16-bit register, and you have some other registers which are called as port 0, port 1, port 2, port 3. All these are come under the special function registers. It has got a 4 KB of only memory. So this is the programming model of 8051. So the internal RAM is the topic today. So looking into the internal RAM of RAM, internal description of RAM in 89C51, it has got 120 bytes of internal RAM in microcontroller, and the addresses ranges from 00 to 7F. So the first part in the RAM is the register banks. It has got 4 register banks which are said to be as bank 0 to bank 3. Each bank has got around 8 registers which are named as R0 to R7, and at a time only one bank will be active. And the second part inside the internal RAM of 8051 is the bit addressable area. The bit addressable area ranges from 20 hexadecimal to 2F hexadecimal, and this occupies around 16 bytes out of 128 bytes of RAM. This has got 128 individual addressable bits. For example, 20, you can see under the bit addressable area, you can see a number called 20. That is a register's address. So each 20 has got about 8 flip-flops. The address of each flip-flop is 00, 01, 02, and so on. It goes to 07. And similarly, as a whole, if one wants to address this register as a whole, he can address as 21. So it means if a person writes as move a comma 21, it means the data from the 21 location, that is the register which with the address 21, will be saved in accumulator. But again, if a bit of a 21 register has to be accessed, for example SCTB setB 08, if I give an instruction as setB 08, so set a particular bit, set a bit in a particular bit addressable area, that means it is 08. Suppose if I give a 08, it means the memory location under the 21 register 08 will be set, that is the flip-flop will be set. So here in this bit addressable area alone, each bit has got an address, and it is both a byte addressable as well as bit addressable. Whereas in the case of a working register where we have about 4 banks, each registers are byte addressable and it is not a bit addressable. And the third subdivision under the internal RAM of 8051 is a general purpose area. The general purpose area ranges from 30 to 7F. So this area is a part where any programmer can access using an address, and here you will not have an English like a letter like R0, R7, R2. You will not be able to use that kind of instruction. Further, you will not be able to use a bit addressable location also. Bit addressable instruction is also not possible with the general purpose area. in general purpose area can be accessed only through direct addressing mode. What does it mean? It means that, for example, if I give an instruction like move a comma 30, it means that the data from the 30th memory location will be moved to accumulator. So this kind of addresses only can be represented in the instruction. You will not be able to use either R0, R1, that is not possible, and a bit operation is also not possible in the general purpose area. Only direct addressing mode, where address can be directly given in the instruction, can be used in the general purpose area. And what is the features of this RAM? So to again I can say that under 8051 you can say it is 120 bytes of RAM, whereas in the read-only memory is 4K. This 120 bytes of RAM is divided into 4 banks, first part, and again it has got a special function register, then it has got a general purpose area. So what are the features? Since it's a RAM, it is a volatile memory, the data will be lost when the power is turned off. And again a processor can read and write the operation fast. And again the temporary, this is mainly used as a temporary storage of data, and the memory is also again little lighter, and this is all on chip because it's a microcontroller. This is all on chip and it can be used to store some data. And again here this is accessible using direct addressing mode as well as through indirect addressing mode. Either the address can be given or else you can give through the indirect, as well as though some feature is not given here, it is the register addressing mode is also possible, because in the register bank location, if I can write as move a comma R0, it is allowed because the content from the R0 will be moved to the accumulator. Whichever bank is active, the content from that bank, the register will be moved to the accumulator. So this is register addressing mode is also possible, though that is not given in the feature. And this is the RAM organization overall picture. You can see here the address range is 00 to 7F for bank 0, 08 to 4F for bank 1, 10 to 17 for bank 2, 18 to 1F for bank 3. And each bank you have about 8 register which are named as R0 to R7. Remember, you don't have any registers like R8, R9. It's not available. Each bank will have the same name like R0 to R7. How a bank will be selected? A bank will be selected based on the status register, what we have seen already. So you have some bits which are called as a register select bit. So from the status register or a program status word, you can have a status register, select registers. Based on that, a bank can be selected. So whichever bank is active, the registers of that bank will be used to save the data. And the second part what you have is a bit addressable area, which ranges from about 20 to 2F. And the last part is a special function registers, where you have a lot of special function registers, some for the timers, some for the ports, some for input output communication, interrupts, serial communication. So you have special function registers too, which we'll be seeing in the later classes. Thank you.